Hello everyone, in this video we're going to talk about how we can solve some logarithmic equations. So what is a logarithmic equation? It's just an equation that involves logarithms of variable expressions, and we can use the following property to solve some types of these logarithmic equations. It says if b, x, and y are positive real numbers with b not equaling 1, then log base b of x equals log base b of y if and only if x equals y. So if we have two logs that have the same base, we can just essentially disregard what the log is, and we can have just whatever we're taking the log of, x in this case, log of y, and set x equal to y and solve. That's kind of the easier examples, right? So for example, if we had log base 3 of x equals log base 3 of 12, then x has to equal 12. All right, now kind of conversely, we could say if x equals 12, then we can take the log of really any base that we want, as long as we do it to both sides, right? Log base 3 of x equals log base 3 of 12. Okay, so it kind of works both ways there. So this property that we just looked at implies that if you are given an equation x equals y, then you can exponentiate each side to obtain an equation of the form bx equals b to the y, because we know that if we have the same base raised to an exponent, then for those to be equal, the exponents have to be equal. So we can use this process called exponentiating to basically take what we have and make those expressions exponents that are powers of the same base. And so then we can use that to help us solve some examples. Okay, so we're going to do 3 examples in this video. Number 1, we're going to do ln of 5x plus 2 equals ln of x plus 10. So notice we're just taking the ln of both sides. So for those to be equal, 5x plus 2 has to equal x plus 10. So now this is a very easy Algebra 1 example of solving an equation with variables on both sides. So I'm going to subtract that x from both sides. I'm going to subtract this 2 from both sides. We have 4x equals 8. Divide both sides by 4, and we get x is equal to 2. Okay, so number 1, easiest type of example that we could get, and we're good there. Okay, now for number 2, we have log base 3 of 10x minus 9 equals 4. So here's where we're going to use what we call exponentiate. So I'm going to take both sides and I'm going to give a power, or I'm going to give them a base of 3. And I'm going to take the expression that we have here on both sides, and those are going to become my powers or my exponents. So this is going to be 3 to the log base 3 of 10x minus 9. And then this one is going to be 3 to the 4th power. Okay, so now this 3 of log base 3, those are going to cancel. So now we have 10x minus 9 is equal to 3 to the 4th power, which would be 81. Now we can simply solve this by adding 9 and then dividing by 10. So we're going to get x equals 9 for number 2. Okay. All right, number 3, last example here, a couple extra steps involved. So we have log base 6 of 6x plus log base 6 of x minus 1 equals 2. So we have a property of logarithms that we can use here. If we are adding these two logs of the same base together, then we can take just log base 6 of the product of 6x and x minus 1. So we could rewrite it like this, log base 6 of 6x times x minus 1, and that's equal to 2. Okay, so now I'm going to take and multiply what I have in there. So log base 6 of, and then this would be 6x squared minus 6x, and that's equal to 2. Now I'm going to exponentiate both sides by raising it to, or by giving both sides a base of 6. So 6 log base of 6 of 6x squared minus 6x equals 6 squared. Now 6 to the log base of 6, that's going to cancel out. And now we have 6x squared minus 6x equals, and 6 squared is 36. So let's subtract this 36 over here, and now we have essentially a quadratic equation, 6x squared minus 6x minus 36 equals 0. So let's factor out a 6, and then we can basically divide both sides of the equation by 6. So once we factor that out, we have x squared minus x minus 6 is equal to 0. And now we could cancel that out because essentially we would just divide both sides by 6. Okay? So now we have x squared minus x minus 6 is equal to 0. And now we can factor this quadratic. So what adds to negative 5 and multiplies to negative 6? Well, that's going to give us an x minus 3 and that's going to give us an x plus 2. So we have negative 3 times 2, negative 6, negative 3 plus 2, negative 1. And this is equal to 0. So now when we use the zero product property, this tells us that x is equal to 3 and x is equal to negative 2. All right, so now when we are solving logarithmic equations, we have to be careful not to get an extraneous solution. So how do we check if a solution is extraneous? Well, we're going to plug it back in and see if up here where we have our x's circled, that's where we're going to plug it in, and we're going to see if we get an apparent solution that once we plug it in, it doesn't work, so that would be extraneous. All right, so let's start with negative 2. So we're going to say log base 6 of 6 times negative 2 plus log base 6 of negative 2 minus 1 equals 2. So we're going to run into a problem here because we are going to be having, or we are going to have log base 6 of negative 18, log base 6 of negative 3. And so both of these logs right here, since we are taking the base of a negative, those are not defined, okay? So since that's the case, we're going to say that x equals 2 is an extraneous solution. Okay, so it was an apparent solution, but when we plugged it back in into our logs, it gave us a log that was not defined. And so in that case, we're going to say negative 2 is extraneous. So let's see what 3 looks like when we plug it in. So log base 6 of 6 times 3 plus log base 6 of 3 minus 1 equals 2. So log base 6 of 18 plus log base 6 of 2 equals 2. Now we could rewrite this as log base 6 of 18 times 2. So log base 6 of 36 equals 2. And we could exponentiate. So 6 to the log base 6 of 36 equals 6 squared. That's going to cancel, and we get 36 is equal to 36. Okay, and that checks out. All right, and so in this case, we would say that x equals 3 would be our only real solution. Okay, x equals negative 2 was an extraneous solution. Okay, and that's how you can solve some logarithmic equations.